thiocyanate equation. This is a very common equilibrium question. Most of the time it's very obvious to see the changes in equilibrium because we're dealing with a colour change here. So it's used a lot, and to understand this will help you understand the idea behind the Chatilius principle with equilibrium as well. So let's get straight into it, and I've got a video explaining how it all works. So here are some test tubes, and each of them contains some iron thiocyanate, which is a reddish colour there. It's reddish because it contains two ions in equilibrium. It's got the iron 3+, which is a yellow colour, and it also has the FeSCN 2+ ion, which is a red colour, the iron thiocyanate. It's a red colour. Now, currently it's in equilibrium, so it has this nice blood red colour here. It's used to make fake blood, actually, this compound as well, so it's very interesting. Anyway, we're going to do 6 things to these test tubes. The first one we're going to do is we're going to add iron nitrate. The second one we're going to do is add potassium thiocyanate or sodium thiocyanate. Not too sure which one we're actually adding because the bottles were labelled wrong, but we're adding some thiocyanate in there anyway. We're adding some ammonia chloride. We're adding some silver nitrate, and then we're going to treat them with hot and cold water to see what happens to this equilibrium and why these things happen. So we'll get started anyway. We'll add in the iron 3 nitrate ion to the first one here. So when we add that in, it's very straight away, very instant, and it changes colour to a deeper red colour. So that means we've got a forward reaction happening here. So what we're doing is we're increasing the iron 3+ concentration, and you can see straight away that we get a sharp increase in the red colour, so the forward reaction is favoured. So the equilibrium has moved in the direction to the right. This is our next thing, sodium thiocyanate. Add this to our second test tube and see what happens. When we add our sodium thiocyanate or potassium thiocyanate, again we get a deeper red colour. So this is increasing the red colour, so we're increasing this amount, so we have a forward reaction happening. So increase the thiocyanate and we increase the products. So the reaction moves forward to re-establish equilibrium. Now we have ammonia chloride, and we're going to add some ammonia chloride to it. So our third test tube here, we're adding the ammonia chloride, and let's see what happens here. So when we add our ammonia chloride, it's very hard to see. I'm going to pause it here so I can see it a bit better. I know, I might bring it forward. What we're doing here is we're actually decreasing the amount of iron 3+, because what happens is it forms a complex with our chlorine ion, so it takes it out of the equation. So decreasing this ends up moving the equation to the left. So to re-establish equilibrium, we move it to the left to reproduce some iron 3+. So it takes away that red colour, and you can see that there. Looking at the difference between those two, you can definitely see it's become a bit lighter in colour. Next, we're going to add some silver nitrate. There it is there, 0.1 molar of silver nitrate. Now the silver nitrate, what that's going to do is going to form a complex, it's going to form a precipitate between the silver and the cyanate ion. And that's going to be a white precipitate, and it's going to take away this cyanate. So what we should see happening is this red colour disappear as well as the reaction proceeds backwards to the left. So decreasing this cyanate, let's put that up there again. I'll pause it here before we get into this. We're decreasing the cyanate, so we get an overall back reaction to re-establish equilibrium. Now each time we do this, our K value does not change. It just, the equilibrium shifts to re-establish that K value. So when we're adding or subtracting our reactants, we're not changing the equilibrium constant, we're just reforming that equilibrium constant, and hence the forward or back reaction does happen. The next thing we're going to do is we're going to get some ice water here, and we have some hot water, which is going to come up in a second as well. And we're going to treat one with cold water and one with hot water and see what happens there. So obviously 2 test tubes placed straight into hot and cold. This is going to take a little bit of time, so let me go through the explanation for this. we've got a delta H for our reaction here. A delta H is negative, so it means the forward reaction is an exothermic reaction. So what this means is that it changes the way that the equilibrium works depending on whether it gets hotter or colder. Now, Le Chat says that we want to oppose a change. So when we want to oppose a change, we want to go in a direction to re-establish whatever we have. So in terms of our cold water, which we're going to show you here now, in terms of our cold water, it's become a bit more red. So because we made it cold, the equilibrium said it wanted to shift into a warmer direction, which is our exothermic direction. So therefore we've got a forward reaction happening there. Our one that we placed in cold water over here, our hot water, sorry, over here, our equilibrium, Le Chatelier said it wanted to oppose it, so it wants to go in the cold direction, which is the endothermic direction, which is our reverse equation. So there you have 6 changes to the one set of compounds, and what happens in terms of their equilibriums when you're, first of all, adding adding reactants is in our first example here, removing products in our second 2 examples, and then changing the temperature in our last 2 examples there. And that's it. And yeah, I hope you enjoyed this thing. What you can do is go away and think about this, and my class are writing a prac about this. So on the Edmodo class, there is a prac sheet where you can record the observations and write the reasons for them as well. So get onto that and listen to the podcasts if you have any other questions about equilibrium. I've got one more video I'm going to upload about demonstrations on equilibrium, and then we're going to move on to our next part, area of study, or not area of study, just next part of this area of study, which is chemistry, economics, and safety, health and safety and stuff like that. So listen to the podcast. You can see the link to it in the description. So, and yeah, just enjoy it. See ya.